Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. And very good evening, everyone. So we will start the class with the Umul Kitab Al-Fatihah. Okay, so without wasting any time, so let's start with our class on the topics of momentums and impulse. So let me do some presentations regarding the topics. This one. So everybody can can look at this and can look at my slides. Can you see my slides?
Yes, sir.
Okay, very well. Thank you. Okay, so the topic is the momentums and collisions. So let's start with the. All right. So on this topic, we will learn a momentum and impulse, conservations and momentums, collisions, and lastly the glancing collisions. Okay. So what is momentum? So the definitions of linear momentum is actually P. Okay, P equivalent to m times v. Okay, m times v, and m is for mass. Okay, m is mass while v is velocity. Okay, it's not speed, it's velocity. So what is the difference between speed and velocity? Definitely because of here. Okay, look at the v here. V here have an arrow. So arrow means this is a vector, and vector is a velocity. While for speed, speed is doesn't have directions. Okay, so because of that, momentum is also a vector. Okay, because of v is the velocity is the vector, therefore momentum is also a vector. And the directions of the momentum should follow the directions of the velocity. And of course, the SI unit for the momentum is kg ms negative 1. Okay, kg stands for this one, and v is ms negative 1. Okay, if I go too fast, then please slow down me. Okay, so this is the examples. Okay, the second slide should be, I've already have got examples. How good are the bumpers? Okay, so in order to understand this, because if you notice in the question, I have asked about the impulse delivered, about the size or directions of the average force. Okay, so some things that before this we learn momentum, but we only learn some things that related to M and V, and it doesn't involve any impulse. So we need to learn about impulse first. Okay, so let's look at these examples, but the KIV first this example so that we can straightly uh, try to discuss about the Newton's second law and momentum. Okay, let's look at the Newton's second law and momentum. So this is the Newton's second law. Okay, the total F is equivalent to the product of mass and acceleration. Force is equivalent to mass times acceleration. Okay, acceleration in this case is based on v minus v naught divided by t. Okay, we have two values of v, which is the final velocity, and the initial is not. Okay, the initial velocity, final and minus initial velocity over time, so we can get acceleration, right? So because of that, if we try to bring these things onto this part, okay, so what will happen? Okay, so we can see that the delta F, okay, is equivalent to m Okay, try to substitute it with V. So V minus V naught over T. Right. Okay, this is also Newton's second law, but what if we try to bring this T to this side? Okay, meaning that Ft is equivalent to M in the brackets of V minus V naught. So what will happen to this point? Okay, what will happen to this side? Okay, does it equivalent to Newton's second law? Definitely not, because Newton's second law is F equals to ma, mass times acceleration. Right now, we doesn't have any more acceleration. Okay, so let's look at impulse. Right. So impulse is actually part of the momentum. Momentum is part of the impulse. Okay, why I'm saying that thing? So let's look at the definitions of impulse I. Because impulse is actually F times T. And according to the previous, okay, what is Ft? Ft is equivalent to mass times delta V. So we can state that, okay, it comes from the F equals to ma. Okay, when you have F equals to ma, okay, forgive for my handwriting, okay, because I'm using mouse, right? So M times with V minus V naught divided by T, so in bracket. So you can easily say, try to bring this T to this side. So Ft is equivalent to mass times V minus V naught. Okay, you can do it on your own too. Okay, so Ft is equivalent to mv minus m naught. So this thing can be simplified by using delta v, because v naught, v minus v naught is m delta v, and in that v is equivalent to Ft. And remember, Ft is impulse. Okay, so impulse is equivalent to Ft. Impulse is also equivalent to m delta v. And if you can notice, m delta v is what? M delta v is equivalent to change in momentum, meaning that I is equivalent to change in momentum. Change in momentum. So that is give you by I. And of course, the unit for the momentum before this is kg ms negative 1. So with the impulse, kg ms negative 1. But impulse, which also have comes from the F and T, so we can also write down as Newton second. Newtons for force and seconds for time. Okay, we can easily get Ft. So impulse is Ft, impulse is also equals to delta P. And of course, impulse is a vector due to due to the force that inside the equations. You know, we already know force is a vector quantity, and of course, the directions of the impulse will follow the directions of average force. Okay, so this how can we rewrite back all the equations. All right, so therefore the same change in momentum may be produced by a large force acting for a short time or by a smaller force acting for a longer time. So in this case, when you see the batter, okay, try to hit the ball, the baseball, okay, that coming on this way, okay, try to do as good, okay, try to hit the ball or smash the ball as good as it can, so that it will create a greater force, okay, to to make his side winning. Okay, so on this side, okay, just look at the previous examples about, okay, before this, yes, and that's why we can we goes back to these examples in the crash test. Okay, crash test mean we do some tests to the car, or to any car, actually any car, in order to get or to see how does the impact, okay, how powerful is the impact, okay, if they make the car from this side, the structure of the car. They want to see what happened to the people who's been they're not doing that things. Okay, the robots should be in the car. Okay, and collides with the wall and rebounds. Okay, that is the word collides. Okay, collides maksudnya langgar dan kepada dinding, dan rebound. Rebound maksudnya kembali tetapi direction dia berlawanan. Okay, the initial and the final velocities. Okay, initial final velocities of the car are V1, Vi equals to -15 and Vf equals to 2.6 respectively. Okay, meaning that from the arrow itself, we can sure that before collisions, okay, the car is going to the left, and after collisions, the car is going to the right. So there are two directions. It is not the same direction. Okay, so because of momentum is a vector, so we need to emphasize on the usage of directions. Okay, the usage of negative and positive. Okay, and maybe slightly in these examples, you are already given, you will be given a negative inside the questions, but that is not the case for the final exam, or maybe your quiz. Okay, because negative here is very very important. So because in the questions itself maybe doesn't have a negative. Okay, so we need to figure out ourselves. Okay, or maybe or going to the right is considered positive, going to the left is considered negative. So we must make sure that we should differentiate between before and after collisions, especially when after collisions it goes to the directions that against when it go dari mana dia datang, dia akan berlawanan tu, so kita tak tahu. So kalau dah jumpa persoalan, when you see that kind of questions, please be careful. Okay, because you need to differentiate between -15 and also 2.6. Okay, remember there's some big significant negative and positive. Walaupun jawapan awak sebenarnya tak ada masalah, betul tapi tolong hati-hati, because in this kind of situation, maybe the negative and positive can give you decisive value lah. Maksudnya kalau jawapan dia tu mesti rupanya kalau letak negatif dapat full mark, tapi tak letak negatif tak dapat full mark. Okay, so kena hati-hati, you must alert. Okay, and of course find the impulse delivered to the car due to the collisions. Okay, so after hitting, so at the point of impact, okay, you know that the impulse is actually I equals to Ft, and I is also equivalent to m delta V. So which equation should we use? Ft or m delta V? Okay, so depending on the informations on the question itself. So in this questions, okay, let's look. So you have mass, you have velocities, and you have time. Okay, so in this case, we cannot use I equals to Ft because we doesn't have force. So we need to apply m, okay, V minus V naught. M equal, okay, m delta V is equivalent to mv minus V naught. Okay, so we need to do that, and of course we need to calculate the initial momentum, which give you negative value, and lastly the final momentum positive value. And then, okay, and afterwards, when you have PF and PI, okay, you can always use a delta P. So delta P is, this is delta P, okay, PF minus PI. So you can get 2.64 10 to the power of 4 kilogram m per s. Okay, that is the unit for impulse and momentum. Remember, impulse and momentum share the same unit. Okay, share the same unit. Okay, and part B, calculate the size and directions of the average force exerted on the car. Okay, so this is using the moment impulse. I equals to Ft, right? So what is F? F is equivalent to I over T. Okay, where can we get I from the previous values? I bahagi with time. What is time? 0.5 5 seconds. Okay, can you imagine if we try to increase this number? Okay, we try to increase the denominator. What happened to the force? Can you guess? What happened to the force? Kalau kita cuba rendahkan T dia, sorry, kita naikkan T dia, apa jadi pada force? Guys,
Decrease.
force kalau kita naikkan dia punya time, force akan decrease. Yes, correct. Thank you. And of course, bila kita turunkan time, force akan increase because it's a vice versa. Okay, inversely proportional. Sorry, it's inversely proportional. Bila yang ni naik, yang ni turun. Okay, bila yang ni naik, yang ni turun. Okay, very good. Okay, girl. Am I too fast? Boleh ya? Kamu dah belajar semua ni. Don't worry much, okay? Okay, so before we can discuss about these examples about the archer and so on, we need to emphasize. I need to emphasize on the needs to learn about this part first. Okay. All right. So this is the conservations of momentum. What does it mean by conservation? Conservation means kekal, conserve. Okay, maknanya tidak hilang. It cannot vanish. Ya, tidak akan hilang, tidak akan musnah. So that's why momentum is also conserved. What does it mean by conserve? Conserve maksud dia tidak akan hilang. It will remain as it is. So you can say when you see conservations of momentum, we can say that Pi is equivalent to Pf. Pi equals to Pf, meaning that momentum at the initial part is equivalent to momentum on the last part. Okay, Okay, so this is the examples that happens when you are canoeing between two canoes. There are a few people on both canoes. So after they actually meet, okay, the canoe one push on canoe two with a force of 46 Newton to separate the canoes. If the mass of canoe one and its occupants is 130 kilogram and the mass of canoe two is 250 kilogram, find the momentum of each canoe after 1.2 seconds of pushing. Okay, so slightly we may need some kind of this part first, okay, before we can talk about the one that related to collisions. Okay, so nak tak nak kita kena belajar pasal collisions. So 6.3 will be collisions. Okay, if you can notice, the collisions we only involve inelastic collisions and another one is elastic collisions. Apa maksud elastic? Siapa tahu? What does it mean by elastic?
Pelanggaran tak kenyal.
Wah, kenyal lah. Apa maksud pelanggaran kenyal? Apa maksud pelanggaran tak kenyal? Okay, so sebenarnya in elastic and inelastic. So elastic, kita tengok dulu perkataan elastic. The elastic means the behavior of the material. Material behavior dia. Kalau di elastic, it wants to get back or to go back to its original conditions. Macam getah kita tarik. Kita tarik, dia mesti nak balik semula ke keadaan asal dia. Okay, so that is the meaning of the elastic. Okay, the ability of the materials to become its original conditions. But always there's always as we have to assume that there is no limit. Okay, so sebenarnya sepatutnya kena ada limit. Maksudnya kita tarik getah tu, okay lah, tapi sebenarnya at one point getah tu kalau dia dah putus, maksudnya dia dah lebih daripada limit dia. Okay, so in elastic collisions, two objects. Okay, so collisions mesti two objects striking one another. Mesti ada macam tu lah. Okay, when itu pelanggaran, kebiasaannya selain daripada tadi, walaupun kereta berlanggar dengan dinding is also considered as collisions. But when you have two objects striking one another, so you can easily differentiate between inelastic and elastic. So two objects striking one another, so there is an inelastic collisions. So what does it mean by inelastic collisions? Momentum is conserved here. This momentum is conserved. PF equals to PI ataupun PI equals to F, but not energy. Yes, kinetic energy is not conserved, meaning that Kf is not equals to Ki. Kef is not equals to Ki. So please, what is in elastic collisions? Okay, and what is completely in elastic collisions? Okay, objects are sticking together afterwards. Okay, so we are saying that when objects are actually stick together after the collisions, so this is the inelastic collisions. Okay, this is a completely inelastic collisions. Okay, between M1 and M2. Okay, M1 is the locomotive 1 and M2 is the locomotive 2, which is not moving. Okay? M2 is equivalent to 0, and when M1 comes with the initial velocity V0, okay, to to strike the V2, to strike the M2. So after the collisions, okay, both M1 and M2. So let's say this is M1, okay, M1, M2. So this is M1 plus M2 because it's sticking together. And if you look carefully, there's only involved one single final velocity, because we will only try, okay, at the end of the collisions, there's only one velocity, final velocity. Okay, when objects are sticking together. During the collisions, okay, during the collisions, some of the initial kinetic energy, okay, why is energy is not the same, okay? Why kinetic energy is not conserved? Okay, because kinetic energy have been converted to other forms such as sound, okay, is such as heat. Okay, and of course, the permanent deformations in the metals. Okay, so this one sebenarnya yang ni nak hafal pun tak payah hafal lah kot. Okay, don't need to memorize this. Just use this thing, this both. Okay, to understand the concepts of inelastic collisions. Ada soalan? Okay, so this is the examples of a truck versus a compact. A pickup truck with a mass of 1,800 kilogram is traveling eastbound. Okay, traveling eastbound meaning that it's travel to the right, because we can say that from our reference, the eastbound should be on your right and the westbound should be on your left. While a compact car with a mass 100 kilogram is traveling westbound, so this side. Okay. The vehicles collide head-on, becoming entangled. Okay, maksud dia bercantum lah. Okay, dia berlanggar dan dia melekat. Find the speed of the entangle. Find the speed of the Find the speed of the entangled vehicle after the collisions. Okay, maksud dia after the collisions dia jadi apa? Right? So we need to find the V. And B, find the change in the velocity of each vehicle. Change. Okay, so let's start all problems with the basics informations. PI equals to PF. Yang ni ramai pelajar tak buat. Sayang, kadang-kadang bila pelajar buat, kadang-kadang bila tak cukup markah, kita boleh nampak benda ni, kita dengan easy boleh tambah markah. Okay, tambah markah dekat soalan tu. Bila kita tengok, okay, you write down the conservation momentum. Maksud you faham lah. Kan? Tak adalah terus tiba-tiba keluar equation ni. Okay, so you need to understand the concepts and basics. Alright. So M1 V1I plus M2 V2I equivalent to M1 plus M2 VF. Okay. So after a certain calculations, the VF is equivalent to 5 meter per second. And there's a delta V1 and also delta V2. So in this case, we get -10 and 20. Okay, and find the change in the kinetic energy. The change in the kinetic energy of the system consisting both vehicles. So you need to calculate the kinetic energy. How to calculate the kinetic energy? Ke equals to half mv squared. For every things, okay, everything on the left side should be not equals to on the right side. So we need to calculate everything. We need to calculate the mass and the velocities. Okay, how many objects involved, because it contains m1 and m2. And you can see here that the initial is 3.04 and the final is 3.38. Okay, so 10.5, 10.4. And of course, the last part will be the change. Okay, how much is the difference between KEF and KEI? So it's stating here negative 2.7 10 of power of 5 joule. Okay, remember, kinetic energy is not kgms negative 1. Okay, kgms negative 1 is for momentum and impulse. Okay, so all the remaining energy is should be equal to joule. Okay, this is about two blocks and a spring. So you have M1 and M2. So this is M1 and this is M2. M2 have been attached to a single spring. Okay, the spring doesn't attach to M1. Collides with a massless spring attached to a second block. Okay, definitely spring tu dia melekat dekat M2. Okay, and M1 ni tadi dia collides, okay, with the massless spring. Okay, next question will be, the spring has a spring constant of 6,600 Newton per meter. Okay, right? So massless M2 2.1 kilogram moving to the left with a velocity of negative 2.5 meter per second, and spring has a spring constant. Okay, determine the velocity of block 2. Okay, so the answer based on this equation, and look at the equation they use. Okay, maybe they should put pi equals to pf. Okay, meaning that initial potential, initial momentum equals to final momentum. So we must always write that thing. Always start with the pi equals to pf, and then afterwards, and when you want to change or you want to do some other calculations, yes, but please, okay, look at all the possible it is, because this is where the main part, this is where the physics part, okay, from the topics, okay, because we need to establish more basic concepts of physics, okay, because we may only focus, we tend to focus on the maths part without thinking that physics is the main things that we want to ask you, not a maths part. Okay, so in here, okay, we can get negative 1.74, and energy, okay, and part B, find the maximum compressions of the springs. Okay, remember, this is the conservations of momentum, this is the conservations of energy, which means energy initial equivalent to energy final, and this one is energy momentum initial equals to momentum final. Okay, there are two things, two different things, because in E, okay, we will use half mv squared, half mv squared, 0. Okay, and this one for F, so we'll have a half mv squared, and half kx. What is half kx squared? Okay, so based on the figure, when M1 and M2 try to collide, okay, in between M1 and M2, okay, there is a spring. This spring is actually damn the motions of V1. So, but in this case, it includes the potential energy. Okay, the potential energy of what? Potential energy of the spring. Okay, so in this case, you can find what is the elongations of the spring at about 17 centimeters. Okay, or 0.173 meters. Okay, ada soalan tak so far? Ada? Okay, On a touchdown attempt, a 95 kilogram running back runs toward the end zone at 3.75 meter per second. A 111 kilogram linebacker moving at 4.1 meter per second meets the runner in and hit on collisions. If the two players stick together, what is their velocity immediately uh, after the collisions, and what are the initial and final kinetic energies of the systems? Okay, so you have two men, okay, coming at the two different velocities. Okay, so let's look after it tangles the M1 plus M2. So we can calculate that VF. But this one you are using the unit vector. Okay, same things like a previous. This is a ballistic pendulum, very good understanding of topics. So collisions in two dimensions. So we'll see later on what is the collisions in two dimensions. Okay, but first tadi kita tengok elastic collisions. So both kinetic energy. So in elastic collision, tadi in elastic collisions, right now is elastic collisions. So the difference between elastic collisions and inelastic collisions is just this one. K F equals to Ki. Okay, Kf equals to Ki. Why? Because in momentum is always conserved in both collisions, but here for inelastic collisions, Kf is not equals to Ki. But in the elastic collisions, Kf is equivalent to Ki. Okay, and because of that, we may have two sets of answers, so two sets of equations that can be included, okay, together, because like I said, okay, this is where, okay, you have object M1 and also M2. M2 is not moving after the collisions. Okay, berlaku pelanggaran. Apa yang berlaku ialah tengok kedua-duanya menghala ke arah kanan. Okay, V2F duduk diam. Okay, and while M1 V1 datang empuk M2 dan akhirnya menghasilkan two different directions. But in this case, it is not always two different direction. Okay, maksudnya elastic collision ni jangan ingat dia satu sini, satu lagi mesti ke arah belakang. Tak, this one is wrong concept. Okay, tak semestinya. Dia asalkan objek itu, okay, tak stick together. Okay, so itu dah cukup lah memadai bahawa that is the one dimensional elastic collisions. Okay, so in this case tengok macam mana dia tulis M1 plus V1, M2 plus V2, M1 plus V1, M2 plus V2. Tengok sampai last kali dia buat macam mana. Okay, so solving for the final speeds. Okay, so don't have to memorize this thing. You try to figure out, okay, how to get the values or how to get the answers for the elastic collisions. Okay, don't have to memorize. Don't jeopardize your brain to memorize this thing, because you need to focus on, you need to understand the basics concept first. Okay, don't use this kind of equations. All right. Okay. Anyone wants to ask the questions before we proceed? Ada soalan? Ada soalan tak? Okay.
No, sir.
All right. Cool. So let's look at the glancing collisions, last part of the linear of the momentum and impulse. Okay, please bear that in mind. We only have 1 hour for this lecture session, because on Thursday you have a public holiday for our Muharram, so you cannot have a class. Okay, so please continue watching the videos of I already give your class rep the link to the videos. Okay, please do all the tutorials that involve a glancing collisions, that involve momentum and impulse. Okay, do a lot of research, do a lot of findings in the YouTube maybe. Okay, try to get try to make sure you know very well about the subtopics. Okay, since this is about two-dimensional collisions that can only be solved if some of the final information is known, such as the final velocity of one object. Okay, so meaning that before this, when we do a collisions, let's say if the collisions is on this line, okay, collisions on this line, and when it meet or when it is, okay, we only cater a problem of M1 going to this side and M2 going to the other side. But every movement will only involve single axis. Okay, let's say this is all about x-axis. Okay, what happens if when you do some collisions and you are expecting that the collisions give you, okay, the same axis after the collisions, but right now, okay, it gives you theta. Theta equals to 66, theta equals to theta. Okay, and what happened to this kind of problem? So that's what we call as the glancing collisions. Okay, meaning that two-dimensional collisions. Two-dimensional, meaning that x and y exists. Okay, let's look at the next example. Okay, this is a car with a mass 1,500 kilogram. Okay, traveling east at a speed of 25 meter per second, collides at an intersection 2,500 kilogram van traveling north at a speed of 20 meter per second. Okay, you have M, you have V, you have M, you have V. So what else? Okay, so find the magnitude and directions of the velocity of the wreckage after the collision, assuming that the vehicles undergoes a perfectly inelastic collision. Okay, it's very good, okay, to understand that this topic, okay, will use a perfectly inelastic collisions. Okay, because other than that, we may have a trouble to get to the problems. Okay, assuming that the friction between the vehicle and the road can be neglected. Okay, so we have to exclude the air friction. Okay, so in this kind of situations, okay, you may have to do it separately between x and y. So let's look. This is the total x initial. This is the total x final. So that you will also have total I initial, total y initial, and this one is total y final. Okay, so you need to do that. This one is your VF. Okay, this one is your VF. So this is a theta. So therefore dekat sini jadi VF cos theta, and this one VF sin VF sin theta. So you may have two different things. Okay, let's look. Okay, a pickup truck, a van travel north at a speed of 20 meter per second is actually going to this kind of situations. Okay, and this car is actually on this kind of equations. Okay, so you need to do it one by one, and then again, okay, try to understand this example. So this should be your assignment. Okay, try to replicate the works for this kind of examples. Okay, right now, okay, cuba ambil gambar, do some snapshots on this part, and then um, try to check all the values whether it's correct or not. Okay, nanti saya akan tanya. Okay, every level tu kenapa dia macam ni, kenapa dia cos, kenapa dia sin, okay, kenapa ada theta, mana data tu pula, Tiba-tiba ada data, tiba-tiba tak ada. Okay, so I'll see you. Nanti kita tengok lagi on this part. Okay. Alright, so kita tengok examples. Two fruits in a two dimensions, analyzing an elastic collisions. Okay. So two astronauts on opposite end of spaceship are comparing lunches. One has apple, the other has orange. They decide to trade. Okay, tukar cerita pasal astronaut lah. Apa yang dia buat di atas spaceship tu. Spaceship we know we have a microgravity. Okay, meaning that bila ada microgravity, apa yang di mana dia tidak akan jatuh ke bawah easily. Okay, boleh akan terapung saja. So astronaut 1 toss the 0.13 kilogram apple towards astronaut 2 with a speed of 1.11 meter per second. The 0.16 kilogram orange is tossed from astronaut 2 to astronaut 1 with a speed of 1.21 meters per second. Unfortunately, the fruits collide, sending the orange off with a speed of 1.16 meter per second and an angle of 42 degrees with respect to its original directions of motions. Find the final speed. Find the final speed and directions of the apples, assuming an elastic collisions. Okay, elastic collisions. So bila ada elastic collisions, maksudnya kita boleh guna dua equations yang berlainan. Tengok yang seterusnya. Okay, equation yang pertama ialah menggunakan Ki equals to value ataupun Kf. Okay, where does it come from? So kita tengok betul-betul ya. This is from initial and this is for final. Okay, and then if you want to get the final marks, it should be in 1.17 meter per second. So from this kind of equations, so from this and this 0.179 0.197 joule and 0. Minus with 0.108 joules, so to get 1.17 meter per second. Okay, but it's not the case yet. Okay, and then of course the involvement of sine and cos, okay, to get 54.8 degree. Okay, you can watch this later, never mind. Right, so this is the last part of the chapter, which means the rocket proportions. Okay, don't have to look deeper on the rocket proportion. It's just to mention it qualitatively, meaning that there's no involved in calculations of the rocket proportions. Okay, so do you have any questions? Ada soalan tentang tajuk yang awak dah pernah belajar ni?
No, sir.
Okay, ada beberapa perbezaan ya. I have to highlight. I have to go to summaries. I have to summarize back. Okay, it's all about momentum. Okay, we learn about momentum. P equals to mv, and we also learn about impulse. I equals to ft, which also equals to m delta v. Okay, the unit for the impulse and momentum is kgms -1. And for impulse, you have another unit which is Newton second, right? So we also learn about the connections between impulse and the Newton second law. And of course, how can we relate that things to the collisions? In collision, we have elastic and also inelastic. In inelastic collisions, okay, momentum is conserved, but not the kinetic energy. But for the for the elastic collisions, the momentum and kinetic energy are conserved. Okay, we also learn about glancing, okay, glancing collisions. Okay, which involve two-dimensional collisions, meaning that okay, we have to do separately between x-axis and y-axis. How to do that? Okay, here, so everything must in the x-axis. Okay, kita kena kumpulkan x dengan f, y dengan y, and last kali baru kita combine dia. Okay, if you look here, this is mk plus vk. Okay, tengok satu-satu macam tu. Mk, ini vk dapat berapa? Lepas tu, yang ni xf ni apa benda pula? Rupanya ialah mk plus M van bila dia dah bertambah mass dia. Okay, VF cos theta. Kenapa macam ni lah? Sebab dia duduk dalam X. Macam tu lah yang saya nak. Okay, so you have one equations, you have two equations. Okay, dua-dua ni you masukkan sekali untuk dapat came up dengan benda ni. And therefore, last kali kita calculate dia punya theta dan dia punya VF. Okay, very good example. Saya tolong highlightkan yang ni. Very good examples. Okay, sebab saya perlu awak untuk lebih analytical. Tak boleh je calculate biasa M kali dengan V daripada dulu kita tahu kan. Okay, so this is about astronauts. Okay. Okay, try to compare lunch. Okay. Okay, so starting from now, you can write down, you can use, you can try to do the next tutorials. Okay, I'm not you are good enough to try to do the tutorial in terms of momentums. And if you do have a problems, then you can ask your tutors. Maybe you can ask me. Okay, do you have any problems? Ada problem tak? Okay, try to continue watching the videos. Okay, try to continue watching the videos.
So upload tak yang recording version ni, yang
mana?
Yang currently kita tengah ni, so upload tak kat YouFuture ke kat YouTube?
Nanti akan upload lah, tapi bukan hari ni lah. Macam tu. Sebab dia kadang-kadang dia takes time juga. Dia nak proses jadikan video kan. So tapi definitely saya akan upload lah juga. Tengoklah, okay, tengok juga. Sebab sometimes saya tak sempat nak upload awal-awal kan. So terpaksa kumpulkan sekali baru boleh upload. Okay. Okay, any more questions? Clear? Okay, so I think this Thursday dah tak ada kelas So